Hello, my name is Joe Hedrick. I am Commercialization Manager for Gas Phase Products for Agilent Technologies in Wilmington, Delaware, United States. We are introducing two new gas chromatographs, the 8860 and the 8890, which are new mainframe gas chromatographs, air bath ovens, which continue the legacy of the 7890 GC that is replacing. They are meant to offer the analyst, the scientist, continuity with what they are doing in gas chromatography, but also to allow them more efficiency as far as being able to know what the state of the chromatographs are, how to perform maintenance, and if there are any problems in its surroundings. So really we're trying to give the analyst more opportunity to do their work and less opportunity to do maintenance, which is taking away from their work. Gas chromatography in general is an enabling technology, and it really spans all markets, all regions. So you will find it in environmental laboratories, looking for residue analysis. You will find it in food laboratories, looking for labeling concerns, nutritional value, residue analysis to know if there is either industrial or pesticide residue in the food you're eating. It really spans, gas chromatography and chromatography in general spans all industries, whether it's materials or what it's used for. It is truly a true core enabling technology for quality control and safety. Process at Agilent for any new project is a white sheet of paper. We start from scratch and we go to the scientists, to the people, to the market that will use our equipment and find out what they are struggling with now. What are their needs, what are their desires, what are their hurdles that they're running into? And from that, we build up a set of requirements and put it into a new product. We try at Agilent very hard with every new instrument to have some core technology which will benefit the industry and science in general. Historically, the clearest example was, it's an old example, but the idea of fused silica gas chromatography columns. It was a Hewlett-Packard at that point, not Agilent invention, but it was something that was invented at Hewlett-Packard, then Agilent, and really changed the way we do chromatography. Right? That was a core technology. The idea of the random access keyboard on the 5890, that was a key enabling technology to give people access and really let them control their chromatography in a very efficient manner. The idea of electronic pressure, electronic pneumatic control is a core enabling technology, which today you wouldn't think about doing gas chromatography without it. So those are examples of the kind of things we try to put into new revs of instruments. The instruments in the pharma industry for gas chromatography, the use cases are fairly defined, extremely defined. Usually residual solvent, maybe excipient analysis. One of the greatest benefits these instruments provide is that they provide continuity, so that it is not disruptive to the standard operating procedure or the workflows the industry is using now. These instruments can very much just sit right on the bench next to the old technology, use the same standard operating procedures, and move forward, whether that laboratory needs extra capacity or is looking to replace something old. These instruments allow them to do that. So it is continuity. It is not as disruptive technology. We've tried very hard with both instruments so that the new features, the smart connected features, scientists can walk into at their own pace. They can do work as they have now, but then get into the new technology as they need to. We are constantly innovating. I think it's no secret. We spend 6% of our revenues on R&D on a yearly basis. We are constantly looking for new things and better ways of doing it, whether it's something like fused silica columns, which is a huge disruption to the market, or whether it's simply a manufacturing change to allow us to make something better so that it does not fail as often. We're always looking at these things.